To begin this presentation on the future of industrial networks, it will be useful to set the scene by having a look at where we are today. So let's start by looking at the advantages of an open protocol. Well, it's supported by multiple manufacturers, software vendors and install and service organizations. There are widely available third-party software solutions for user interface creation, trend reports, alarming and other applications, much like apps for smartphones. They provide easy communication with subsystems such as lighting and chiller controllers. There's an active community group for support, for freeware, for influence with vendors, and they provide the ability to stay current and add capabilities in the future. So what are the advantages of a closed protocol? Well, generally they offer faster speeds, they offer faster development, and from the manufacturer's perspective, they can allow for some unique features. Wireless network technology is growing fast, so what advantages do they offer? Well, they offer easy and low cost of installations, especially for existing factories and buildings. They provide scalability through easy addition of devices. They can be compatible with wide systems, usually through gateways. They're a good solution for large factories and facilities, and where it's not practical to run wiring between buildings and maybe over roads where civils work might be required otherwise. What are the advantages of traditional wired communications? Well, they're fine for new construction projects where running wires is not a significant extra expense, and they are definitely more suitable where high energy equipment could interfere with wireless and where performance and reliability is critical. So let's look at the different types of automation networks. Many have said that field bus would be dead 20 years ago, and yet buses like Profibus and Modbus are still thriving. Existing plants are very unlikely to replace a functioning network technology, but at least on a large scale, just because it's old tech. Ethernet-based protocols are of course seeing significant growth, but as we will see, field bus still dominates. We're seeing a decline in process networks as Ethernet becomes more widely used. Even Profinet is being developed now as an EX network by the Profibus group, using intrinsically safe switches. Wireless protocols, as I've said, are growing in popularity and are showing the fastest growth according to the statistics that we'll see in a moment. And it's using technologies like WLAN, industrial Bluetooth and Zigbee. There is a huge range of building protocols. However, we are seeing a big move towards convergence with factory automation devices and protocols in smart building applications. There are still many legacy networks deployed which are still being utilized. Therefore, there's a big need for us to integrate with these more easily to modern networks. Another key growth area is safety buses such as ProfiSafe and SIP-Safe. It is worth noting that normal SIP and Profinet devices can happily work on these networks, such as the HMS wireless bridge, providing they have no safety function. The master must, however, be a safety-specific master. Let's take a look at where industrial networks are today. To set the scene, let's look at something significant that happened in 1976, and I am not just referring to the birth of our marketing manager. A chap called Bob Metcalfe introduced the Dixie standard, supposedly the answer to all protocol problems using open Ethernet format, and he did this with Xerox and Nixdorf. Previously the standard was an ASCII-based standard over Ethernet. So let's take a look at how that worked out. Clearly this didn't quite go to plan. Up until the noughties, it was mainly proprietary networks that developed and dominated. By 1995, the industrial networks market was very diverse as end users put pressure on device manufacturers to offer increasingly open communications. By 2017, this situation had gotten even worse, and there are so many we don't even list them all. There must at some point be a convergence. Networks like Interbus S are fading away, as are many others. Open protocols are an expensive hobby and need a big sponsor and big money behind them to keep pace with technology trends. We also need to consider these two big networked industrial sectors, factory automation and building automation. It's estimated that the factory automation market is around $150 billion, and not surprisingly, the main players in this area are Siemens and ABB, Schneider, Rockwell and Mitsubishi, and the applications won't be a surprise either: PLCs, drives, robotics, sensors. Dominating technologies are things like Profinet and Ethernet IP. In building automation, the market size is estimated at $50 billion. Some players are the same, but the main players are Honeywell, Schneider, Johnson Controls, Siemens and ABB, with applications like HVAC, lighting, fire alarms, access control and security. The protocols are different and specialists, such as BACnet, KNX, LON, DALI and many others, but our old friend Modbus is in there. There are some key technology differences, but we are seeing these industry sectors starting to merge. In factory automation, we're typically looking at mission-critical applications and real-time information. In building automation, it's typically not mission-critical. It's non-real-time. If a room has to heat up, it doesn't matter quite how fast it is, at least not in any sort of critical sense. You also see in the building industry domestic and commercial connectivity and hardware, and it's often used in the building sector. It's cheaper because the demands on it, environmentally, performance, IP ratings, etc., are low. Industrial devices require higher performance specifications and longevity, and therefore command a higher price in order to be ruggedized and tested to a much higher standard, and this has probably held back the merge to an extent. So, what is hampering the growth of automation networks? Well, many low-end devices just don't have the space or processing power to connect to modern networks, especially when we're taking into account ever physically smaller sensor equipment. A lot of these existing devices also have processors that simply do not have the capability to run modern networks, such as Profinet S2. All of the open networks that we're familiar with are licensed, and companies who use these technologies generally must pay a license to use these protocols, Modbus being an exception, hence its continued popularity. And incidentally, Modbus Secure is coming onto the market soon, so Modbus continues to thrive. When field buses do finally die out, many believe that Modbus will be the last to go, just as it was one of the first open protocols, albeit by default and by accident. So let's look at some trends. Fieldbus still dominates, but has the lowest growth. Ethernet-based protocols are growing and will likely overtake Fieldbus very soon. But wireless networks are showing the largest growth, and as you can see on the chart there, looking at about an annual growth based on 2017 figures of around 32%. There are variations in trends geographically, and these stats reflect who are the dominant service suppliers. If we look at Europe and the Middle East, the fastest growth rate is still in protocols such as Profinet and EtherCAT, followed by Ethernet and PowerLink. Profibus is still dominant, and our old friends Modbus, TCP and RTU are definitely there, and CAN and CAN Open are still used in new installations. In the US, not surprisingly, the SIP networks dominate. Ethernet IP is a leading network. EtherCAT is gaining market share, but again, Modbus, RTU and Modbus TCP are still popular. Asia, though, is a fragmented market. No network really stands out as truly market leading. Profibus, Profinet, Ethernet IP, and Modbus and CC-Link, there's so many that are all widely used, but there are early signs of CC-Link IE field being adopted. In my experience, no one's ever asked me what devices I can connect to a network like DeviceNet, for instance, but I have been asked many times, how do I connect my Siemens kit to DeviceNet? So it seems the PLC always dictates the protocol to be used. So, what are the big technology trends? Well, there's a steady stream of new technology and terminology appearing in the automation industry as part of the big push towards Industry 4. Everybody is talking about big data at the moment, but people struggle to understand how to implement this concept. There's also deep data, which is data from down at the sensor level, proximity switches, for example, but there is not currently widespread hardware availability, and where it exists, it's expensive. And of course, there is a lot, and I mean a lot of hype about the coming of AI technology. Well, maybe we'll reach the point where a sensor can not just detect an object, but will also know how it felt while it detected it, but that's a long way off. Key buzzwords to look out for are things like BYOD, which is bring your own device, and we're talking here about using devices such as Apple iPads connecting into industrial systems, maybe via wireless, to monitor data through HMIs. Cybersecurity is a critical issue, it's not just a buzzword, and big data we've already mentioned and will come up again. To highlight this massive change in connectivity, we can look at this analysis chart. This was produced by Ericsson a few years ago as part of the Network Society Cities of the Future report, and makes for very interesting reading. They took a 100-year period from 1975 back, and in that first 100-year period, we reached a point where we had 1 billion connected places. In the following 25 years, up to the year 2000, we achieved 5 billion connected people. This is using technologies such as mobile phones and the internet. It's predicted by 2020, largely thanks to the Internet of Things, we'll be looking at 50 billion connected devices. This also explains why we need to upgrade fairly soon from IPv4 standard to IPv6 to cater for this growth in devices. But of course, the driver for us is not just the Internet of Things, but the industrial Internet of Things. So what are the key elements to the industrial Internet of Things? Well, there's our familiar territory here, the industrial automation and communication, referred to as OT, operational technology. This is a mature industry with clear rules and established technologies, but it is increasingly being changed by drivers from the IIoT, demands for IIoT. Sitting at the top end there, we have IT, or IIoT, the information technology area. We're seeing this using emerging and evolving technologies. There are different adoption rates being seen in different end-user industries, but IT are now a key stakeholder in this area of our industry, and security is critical for them. We're seeing new ecosystems emerging with new players, such as ThingWorx and companies like that, Microsoft Azure, Amazon, and we're going to see new partnerships and alliances emerge. The reason for this is that the integration between edge devices and an effective cloud solution requires partnerships with special developers to maximize the return on investment. So what is the edge? Well, the edge sits right between the two. It sits in the IT area and offers a well-documented, good and secure and easily identifiable data from the OT area. The edge is the borderline between the OT and IT environments. The factory automation engineer will need to learn the language of IT, as this is ongoing convergence is going to happen. HMS, for example, launched the .NET Gateway to directly bridge between OT in an industrial network familiar to FA engineers and IT familiar to IT engineers, a clear example of an edge gateway. Industry 4, at least in networking terms, requires the bridging of the OT and the IT world, and we see specific and different requirements in each of these areas. The cloud gives us scalability for data storage, which is easy to manage as it grows, rather than the limitations and costs of maintaining on-site storage of this data. Bridging the OT and IT gap opens up exciting new opportunities, as we'll see in the IT area. So we can see new opportunities here for things like smart operation, where day-to-day operation of a facility is made more efficient. We can look at things like better quality control and the implementation of things like AR, augmented reality, and VR, virtual reality. HMS itself has seen a lot of interest in smart maintenance with condition monitoring and analytics. Machine learning is particularly a big area of interest. This is all about predictive maintenance. This is about maximizing the availability of the production by anticipating problems. We have smart service, where we're looking at things like remote access applications, lifecycle management, asset management, again, maximizing the efficient use of our facilities and our people. Smart information, the area that's going to be of interest to business people, which is key performance indicators. This is getting the best out of their staff and systems and maximising profitability. And last but not least, smart sustainability, looking at applications like energy management and resource management. Again, partly for financial reasons, but also for environmental reasons. So in summary, we're seeing the rise of bridging protocols such as OPC-UA, MQTT, and increasing use of APIs such as REST. We might eventually see OPC-UA replace many automation protocols. For now, though, the need is to effectively bridge between FA protocols and the clouds using the Industry 4 protocol solutions. Somebody recently said to me, and I agree with them, data is the new oil, and it's increasing in value by the day. Thank you very much for listening.